So this should be a nice little change of pace, okay? We are, however, going to be doing a lot of graphing of coordinates. Okay. All right. So a vector. Anyone want to tell me what a vector is?
I'm thinking maybe if it's like an absolute value where it reflects on both sides, maybe the point in the middle where it reaches the x-axis is the vector.
Okay, Ben.
The initial starting point.
Okay.
Oh, direction and magnitude.
Hey.
I want you to say that, but I didn't want to interrupt.
I'm applying for a new villain loan
Oh,
by the
it's-
name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Okay, so what's the vector?
A line, a direction, one with. Where's it? Where's the start of it?
So a quantity with both direction and magnitude. That's his name because his crimes have direction and magnitude. Oh yeah. Okay. It is represented with an arrow. This would be the vector JK.
Just like a different name for a line.
No. What is the magnitude? So magnitude refers to the length of the vector. The direction refers to the direction it's pointing to, right? So when you get into pre-calculus, you'll do actually a lot with vectors. And you'll do so much as to actually like find like what this angle is. Like, is it 30 degrees? Is it 20 degrees? Is it 200?
Northeast.
Okay, so yeah, you can get all sciencey on us here. Okay, now we're not gonna go that far, but what we're gonna do is we're gonna talk about the different components, and these are gonna help us like take a shape in the coordinate plane and move it with a vector. That's what we're gonna be doing.
Magnitude, like the same as like the magnitude of like an earthquake.
So the magnitude of a vector is how long is the vector, okay? Kind of like a distance formula sort of thing there. Yeah, we're not gonna do that. We don't have to do that, okay? All right, now, what we do need to talk about is our different components, okay? So I want you to go down here to component form. Okay, so when we talk about the component form of a vector, it takes into account the horizontal. So this is like a sentence, component form of a vector. Okay, so it's going to take into account both the horizontal and vertical components. I'm going to show you what that looks like.
I mean by like going as far as like East, north, east, south. No cardinal directions in that.
You would be surprised. Okay, so let's talk about the vector 2, 5.
I can only tell which way is north, east, south, and west of the city.
This means my horizontal component is 2 and my vertical component is 5. So when I draw my vector, okay, I'm going to go right 2 and up 5.
Why does it look like the greater than less than symbols are in there instead of the normal currency?
Okay, so these are called chevrons, okay? They indicate we're talking about a vector instead of a coordinate, okay? If I wanted to plot a coordinate, I would go right 2 up 5 and I just plot a dot. This time we're gonna go right 2 up 5 and we're gonna draw an arrow.
That sounds like a car model named Chevron. There's a gas station.
So this pattern was really popular for a while, like in design.
Yeah.
These are chevrons. You know what I'm talking about?
Like Charlie Brown?
Like Charlie Brown shirt, yes. Okay. All right. Now, if I wanted to plot the vector -2, -3, okay, then I would have to go to the left 2 and down 3 and then create my vector. Okay, so yes, you're right. It looks like we have a coordinate, but the chevrons tell us, hey, draw an arrow instead. Now, we are going to use vectors to create a transformation with a shape. Okay, now all of this chapter, we're going to create transformations and we're going to talk about specific ones. Okay, so a transformation. If who can just describe to me what a transformation would mean? Like, not necessarily in math, but a change. Okay, if I have a transformation, that means maybe I look different, right? Like, oh, it's been a big transformation, okay? It's different, okay? So when we talk about a transformation of a graph, we are going to change either the position, the shape, or the size, okay? And we're gonna just like each day talk about a different one, okay? Now, we're going to talk about an image and a pre-image. Okay, and those are the two different terms that we're going to use when we're talking about basically original and new. Okay, so the pre-image would be our original figure, but then the image is our resulting figure. All right, so today we're going to focus on a translation. And a translation is really just what we're gonna call a slide. We are going to take our shape and we're gonna slide it. Maybe we're gonna slide it right, left, up, down. Maybe a combination of right and up or left and up, whatever. Okay, we're gonna take a shape and we're gonna just slide it in the coordinate plane. Okay, when we make a translation, it is one of our rigid motions. A rigid motion means that both the image and pre-image are congruent. What does that mean? They're the same size, okay? They might be in a different position. They might be oriented differently. We're gonna have 3 rigid motion transformations. Today, we're gonna talk about a slide. Tomorrow, we're gonna talk about a reflection. Tuesday, we're gonna talk about a rotation. Okay? Those are going to be our rigid motion. So let's talk about this translation. Okay? There's 2 different ways we are going to notate it. Okay? So I could give you a vector and I could say, hey, we have the vector 6, -5. Okay? Huh? I do. Okay? If we're using the vector 6, -5, then what that means in terms of the the translation, you could see it written like this: X comma Y with an arrow. Okay. What does the vector 6, -5 mean? We are going to move which way 6? Right? So we're going to add 6 to our X coordinate because we're moving to the right. -5 would mean we're moving down 5. So we're going to subtract 5 from our Y coordinate. So you might see the vector, or you might see this notation right here. X comma Y goes to X plus 6 comma Y minus 5. It's just telling you, hey, move it this direction. Okay. If you can graph coordinates and you can count, you're going to be great today. Ben, can you plot coordinates? Sometimes.
Yes.
Okay, Nora, can you count? Okay, we're gonna be okay. Harvey, can you count?
Yeah.
Okay, good. I'm feeling something. Okay, let's go to our new set of notes in our packets, and I want you to go to page 1. Oh, Harvey, you didn't actually put this in your folder. You didn't put this in your folder.
Like when the graph,
This will just be a pretty short unit.
Yes, it will be a pretty short unit.
So we're gonna take a test on.
Yeah, not a problem. So it's like 2.5 weeks.
It's a good quiz. It's a good quiz.
Do you want to be a good grade? Or do you
So
want to be a
here's the
test
deal. I could, if it's a not a very difficult test,
Easy points.
so stop. Chapter 3 was, that test I just gave you was not a very hard test.
What'd you get?
Doesn't matter. Grades don't matter, only for you. Okay. All right, so please explain to me, Sam Beiser. If my translation rule is X comma Y goes to X plus 5, Y plus 1, which way are we moving 5? Thank you, Sam. So this means we're gonna go to the right, and this means we're gonna go plus 1 with the Y means we're gonna go up 1. So here is A, here is B, here is C. We are literally going to take these three coordinates and we are going to move them right 5 and up 1. So I'm going to start with A. I'm going to take A and I'm going to count 1, 2, 3, 4, 5, and then up 1. And I'm going to call this A prime. That little tick mark, it's a prime. And that's what we label our image with. If the pre-image is A, our image is now A prime. What is that coordinate? 2, 2. Great. Now I'm going to go to coordinate B, and I'm literally going to count 1, 2, 3, 4, 5 to the right, and then up 1. There is my B prime. Brayden, what's that coordinate?
B is 4 or negative
4, negative 1. Okay. Then we have C. I'm going to literally count from C. 1, 2, 3, 4, 5, up 1. There is my C prime. What is that coordinate?
4, 1. Just move.
Okay. That is 4, 1. There is our image. It is congruent to the blue triangle you see before you, because we literally just took the coordinates and we slid them right 5 and up 1. Now, I think it is in you're going to have to graph it anyway. So I think that you should just count on the graph and then tell me your coordinate. However, you'll also notice that -3 goes to 2 because we added 5. 1 goes to 2 because we added 1. You see that pattern? Ben.
You're like making like translation. Does it have to be like dotted so you know?
So I am gonna do that, but you can draw it normal. Okay.
Wait, so it is your ways to just add what the X and the Y.
I didn't say easier.
Another way.
Okay. So you have 2 options. You can use this rule, get these and plot them, but you're gonna have to plot them anyway. So I think it's easier to plot them and then read the graph. In my opinion. Okay. All right. Now look at the second example. Notice how I've given you this time a vector. I also didn't give you that. Okay. So let's go ahead, and what I want you to do is, first of all, go ahead and plot your pre-image. Please label your coordinates. So I'm labeling A, I'm labeling B, I'm labeling C. There's no lines?
Like the vertical lines are like
There's no
very
vertical
thin.
lines.
Oh, I hate when it doesn't print well. I'm sorry, guys. Can you prove it? Yes, yes, you can.
Yes, I can. Because no sides are equal.
You could do the distance formula to actually show me that.
Yeah, why don't you do that then?
Okay, here we go. I have given you the vector 0, -3. What does that mean? Okay, we're gonna map our coordinates where the X doesn't change, but our Y's need to go down 3, is what that means. So I'm gonna take literally all of these and go 1, 2, down 3. 1, 2, down 3. 1, 2, down 3. Boom, there is my new triangle. are our coordinates? -4, 0, -1, -4, and -5, and -2. Okay. All right, so now what I want you to do is I want you to look at this example right here. Don't write anything down. Just tell me how we get from pre-image to image. You and your partner make a decision. How do we get from pre-image to image?
Five, right, 2, 5, 2. Oh. Oh, you 4 over, nope, it's 2. It's 2, so 4, 2, 4, 2. What's it?
Okay. Alexa, how do we get from pre-image to image?
4, up 4 over 2.
Up 4 over 2. Okay, so what you're saying, right or left 2? So we need to go right 2, and we need to go up 4. Okay, so if we need to go right 2 and up 4, because right here, this is our pre-image, right 2 means we are adding 2 to our x, and up 4 means we are adding 4 to our y. In component form, we would write the vector 2, 4. Please make sure you look at the horizontal movement first, because that corresponds with x, and then the vertical movement second. So how about you actually look at the next example and write down the rule in component form.
If the X doesn't move, do you not have to write down the?
So, but you would need to,
Like, it goes down.
so the rule needs to look like this.
Oh.
That is going to be the habit of don't include. It's not checking the fine.
Okay. Oh my goodness, we're not gonna make it. All right, so Braden has written down component form is 0, -5. Do you agree with him?
Yes.
Okay, which means our rule is that x comma y gets mapped to x comma y minus 5. Do you agree with that? That was a lame example. Lame. Who chose that? Okay. Now, it is possible to have a composition of transformations. So basically, we are going to graph our S. We're going to do not only 1, but 2 transformations. Okay, so let's go ahead and let's graph our S. So R is at -3, 5. And S is at -1, 2. Okay. Okay, I'm going to highlight it in pink, and that's the color I'll use up here. Nora, explain to me what we need to do for our first transformation. Which way do we go?
Right 3 down 5.
Right 3, down 5. So let's go right 3. Or are you at the origin for R prime? Okay, good. Right 3, 1, 2, 3, 4, down 5. So I'm going to label that R prime and S prime. Now, what we're going to do is from that new one, we're going to do the second transformation. So from R prime and S prime, we are going to go which way 5? Left 5 because it's with the X and up 1. So I'm going to go left 5 and up 1, and we're going to call that R double prime. So we're going to put 2 tick marks there. Okay. Left 5 up 1. And in this one, I'm just having you graphing it. I'm not saying, hey, give me the coordinates. It was just a graph. Okay, could you turn the page, please?
So do they always go in order from top to bottom?
Yes. Okay. Your homework is page 2 and 3. This is the 4.1 worksheet. Are you whining over there? It was Brayden then. Brayden's the whiner.